In this third video, I want to talk about our next sort of structural or architectural structure, which is the truss, and how tension and compression act in trusses. So just to remind you yet again, compression is when you are pushing on a material, tension is when you are pulling on it. So let's return to our Romanesque church. You can see the arches, the nice Roman arches here, and the columns here. So most of the walls are built out of stone and the walls are compression. But if you look up above, what you're going to see is that the ceiling is missing, but the wooden framing that is holding up the roof is made of wood. And it is made with wood that is arranged in a triangle, or a series of little triangles. And these are called trusses. So we're going to look at trusses. They're a very important structural member that are used all over the world, and I can guarantee if you look around your school campus, you're going to have trusses. And my house, for example, I know it has trusses up in the ceiling, or wood, very similar to this, but you can't see them, of course, because these ceiling panels are blocking them. So let's talk a little bit about how trusses work. So this is a typical wooden truss that's found often in many homes in America and New Zealand. It's a wooden frame that is made up of different components or parts, and when you nail them or bolt them together, you get a whole series of triangles. And then typically on top is all the wood framing and the roof materials. And so you can put a very heavy load on a truss. It could be covered in snow, and the truss will support the roof. So how does it work? Well, the way it works, unlike a beam which bends, what goes on with the truss is that when you apply a load down onto it, then if you look at this piece of wood here, that's getting pushed down like that, and at the same time it's being held here, so it's being pushed up, and so it's also being held here, it's being pushed up. So in this portion, these pieces of wood are under compression. Whereas down the bottom, what's going on is, because of the load is coming down like this, it's pulling out like this. So the bottom member is in tension. So unlike a beam where you can have both tension and compression happening in the beam, what happens in a truss is that each piece of wood is either totally in compression or totally in tension. Let's look at it if we're hanging a weight. So imagine we're hanging some sort of weight off here. Then of course what's going to go on is that you've got pulling down, the weight is going to pull down here, and that's going to cause tension. This should have tension here. So that word should be tension, by the way. So we'll have tension in here, and because it's pulling on these, that's going to cause the beam at the top to be pulled inwards at both ends, and so we have compression here. So this series of triangles that make up trusses, each member or element of the truss is either in tension or compression. So here is that diagram again of a typical roof truss found in many homes in the US and New Zealand. And then below I'm just showing you what happens when you put a load on it. So the red is representing the members of the truss that are in compression, and the green are the members that are in tension. It is quite challenging to understand what's exactly going on a truss, and it's a little bit more advanced engineering, so we're not going to bother with that in this class. But just the main thing to be aware is that each section is either in tension or compression. And it actually changes. Which section is in compression or tension varies depending on where the load is being placed. So in the ancient world, we're not sure who invented the truss. There is a lot of archaeological debate whether the Greeks actually invented trusses, because there are some Greek temples where the distance between the columns is so great that we're pretty confident that a wooden beam couldn't have spanned that distance. And when you actually look at the notches in the stonework, The notches are quite small, and those notches are where the wooden beams were held. So we think that maybe the ancient Greeks had started late in their history using trusses to span larger spaces. But we do know that the Romans made full use of trusses, and that many of their structures had trusses, and that allowed them to span very large areas. So here is an example. You can go and visit this ruin. It's the Domus Flavia in Rome. This was the imperial court or palace, and there's one particular building which we're seeing right in the center here. This big space. Look at the human figures here. This big space. This big open space. And this is the triclinium, which is sort of like a big sort of meeting hall. And you can see here's the roof. And then what I want you to notice is that up here, we believe that this whole area was spanned by wooden trusses. There's no other way they could have done it. There's no dome here, there's no arches here, there's no beam that would have gone across here. So the only type of technology they could have used is wooden trusses. And so this gives you an idea of what the space probably looked like. Up the top here is the ceiling, which is totally sort of blocking out the trusses. But you want to imagine there's wooden trusses sitting up in this space up here. And it's a truly massive space. So you couldn't have created these large open interior spaces using, basically the proper lintel system, or even arches with the materials that they had back then. So remember, they didn't have any steel. They just had stone and concrete and wood. So this space was, this large massive space was created by the use of wooden trusses up in the ceiling. So today trusses are used all over the planet. They're really common. You see them all over the place. These are some examples of some different trusses. You don't need to know the names, but if you keep your eye open, you'll probably see lots of examples, particularly at bridges. So here is a railway bridge that crosses over the Mississippi in the US, and it's made out of steel, but it's all built up of trusses. And then of course here we have the Eiffel Tower. It is also made out of steel, but if you look carefully up here, you can sort of see that you have a whole series of little triangles. So this whole structure is built out of trusses. It allows you to make it very, very light, but also very, very strong. So one of the things that I'd like you to do this week is to try and make a truss out of either ice blocks or popsicle sticks, and just test it out and see how it works. And compare a triangle to a rectangle. See what happens when you make a shape that's a square or rectangle, and you try to put a load or push on top of it. It will collapse, but if you do it with a triangle, it's not going to collapse. And also keep your eye out, see if you can take some photographs or find examples of trusses. And I bet you most of the large open spaces on your campuses, things like auditoriums and gymnasiums, are probably held up with steel truss beams.